Welcome to Chapter 11. We are at the point now where we may be taking Cornell notes without the guided portion. This means that you have blank notes that you need to fill out. That doesn't mean you should write everything down. You'll still continue to write down the objective and the essential question, but from there it'll be up to you to decide what the most important information is. After you take notes, it's even more important now to go back through and highlight and underline or circle information that is truly important, because you may have written down things that were beyond what you need to know for the exams. So let's start with the objective. Learn to write and identify equivalent expressions using fractions, decimals, and integers. And our essential question, how do I combine like terms? A few vocabulary that we need to talk about would be terms, like terms, equivalent expressions, and simplify. We've already worked with some of these. Terms in an expression are separated by plus or minus signs. So if you look at what's in color, we have 7x, 5, 3y, 2x. Those individually are called terms. Like terms can be grouped together because they have the same variable raised to the same exponents. So the blue ones, the 7x and the 2x, could be combined together to make 9x. Constants such as 4, 75 hundredths, and 11 are like terms because none of them have a variable. Equivalent expressions, we've talked about those in the first two chapters, have the same value for all values of the variables. Just means that they equal each other no matter what. And to simplify an expression, perform all possible operations, including combining like terms. Similar to simplifying a fraction, we combine as many terms as we can until there's nothing left to do. So this doesn't mean you're going to get down to a final number for an answer, but an expression where you might have x's and y's and numbers. Quick reminder, a coefficient is a number multiplied by a variable. So in example A, we have 14 times A, 14 is the coefficient. 5 times A, 5 is the coefficient. So in example A, we're combining 14A minus 5A. That's no different than just subtracting 14 minus 5, because both have A to the first power. So when we subtract those, we get 9A. Example B, we have to look and see what sort of like terms we have. So you can see that we have a 7y squared and a negative 3y squared. Now I say negative 3 because when we look at these, we pay attention to the symbol in front of them. Because when we start to combine, we have to follow that operation, either subtraction or addition. We also can combine the 8 and the minus 1. And the y is its own term that can't be combined with anything. So 7y squared minus 3y squared is 4y squared. Positive 8 minus 1 is 7. And y is y. See the order that they're written in. We had the 4y squared first, plus y plus 7. Typically, you'll see starting with the highest exponent, working its way down to the constants. Combine like terms, 4q minus q. If we see q there, that means that we have 1q. If we go to combine 4q minus 1q, it's going to give us 3q. Example B, 5c minus 4c would go together, and the minus c. 8 minus 2 goes together. So now we have three terms to combine. So 5 minus 4, and then minus one more. So if we take 5 minus 4, we get 1c. 1c minus another 1c leaves us with 0c, or just 0. So what we end up with is the number 6, because 8 minus 2 gives us 6. Combine like terms one more time. We can combine the 5t squared minus 2t squared. Combine 7p minus 3p for a total of 3t squared plus 4p. If you were to write these in the other order, 4p plus 3t squared, that would be equivalent as well. There are cases occasionally where you look at the variables and the constants and realize there is nothing that can be combined. So in this example, 4m to the third, 9n, and 2, they all have different variables with them, so we cannot combine any of them. Let's do a refresher. Distributive property. Back in chapter 1, we talked about commutative, associative, and distributive. Distributive is the one we're going to focus on. Remember, what that looked like was taking an outside number, multiplying everything that's inside of parentheses by it. This is also known as the truck and trailer method. So let's think about this. Okay, let's say that we're going to haul something. We're going to haul 5 tons of rocks. All right, we have 5 tons in the truck. We're going to pull the trailer behind it, and we're going to pull 3 more tons. So this truck and this trailer are going to go together, and they're going to make a total of 5 trips. So if we make a total of 5 trips, and we want to figure out how much we're hauling, we are hauling 5 tons plus 3 tons every time for a total of 5 trips. So we could go ahead and add together and get 8 times 5, or we could distribute. So the truck is going to make 5 trips, which is 5 times 5, plus the trailer is going to make 5 trips as it's attached to the truck, which is 5 times 3. That gives us 25 plus 15, and 25 plus 15 equals 40. Okay? We could come up with an equation for this. So let's change this now, and let's say that the truck can carry 5 tons every time, and the trailer can carry X amount. So then we can say any number of trips. So if we're going to make, this time we're going to make 4 trips. So we can haul 5 tons plus X amount, and let's come up with a simplified formula for this. So 4 times 5, and that's going to be 20, and the trailer will be 4 times X, which is 4X. Okay, so let's go through this and see how many tons we need to haul if we wanted to get maybe 120 tons total. So if here's my equation, we're going to haul 4 times, and I want it to be a total of 120. Let's solve the equation. So subtract 20 from both sides. So 4x equals 100. And then divide by 4. So x equals 25. Now, that seems a little unrealistic because 25 tons in the trailer, the size of it doesn't look like it can haul more than the truck. But this is an example. Things aren't to scale. So we're just showing that we can use a distributive property, and the distributive property can help us to set up an equation in which we need to solve. So we can simplify. So let's go ahead and look at what this would be if we distributed. 6 times 5 plus 6 times n. We get 30 plus 6n, and because the minus 2n is on the outside of the parentheses, that does not get distributed. Now we need to combine like terms. 6n minus 2n would be 4n. That's as far as we can go. Let's try another one. Distribute 3 times c plus 3 times 7. Again, leave the c on the outside alone. So 3c plus 21 minus c. Combine the c terms to get 2c plus 21. As you finish this, make sure your notes are filled out completely. So what that looks like is that you've put down examples that we've gone through, any new vocabulary terms that you did not previously know. On the left-hand side, come up with questions that could be answered from the material in your notes. Review your notes, highlight, underline, etc., and complete the summary before class.